Okay, so this first question is about collisions. So momentum. It says two particles P and Q of masses zero point 0.2 and zero point 0.3 kgs respectively are free to move in a horizontal straight line or a smooth horizontal plane. Okay, and 0.2 and 0.3. P is projected towards Q with a speed of 0.5. At the same instant, Q is projected towards P with a speed of -1 because it's in the opposite direction. Q comes to rest in the resulting collision. Find the speed of P. Okay, so the formula for momentum is momentum before impact equals to momentum after impact. So I get 0.2 into 0.5 plus 0.3 into -1 equals to 0.2 into V plus 0.3 into 0. Okay, solving this gives me what? 0.2 into 0.5 minus 0.3 divided by 0.2. I get minus 1. So the speed is 1 and the direction is reversed, although the question isn't asking you about the direction. Okay, a car of mass 1400 kgs is traveling at a constant speed up a straight hill inclined at alpha degrees to the horizontal, where sine alpha is equals to 0.1. Okay, when it says constant speed, it means acceleration is 0. Okay, we have to quickly draw the gravity and resolve the force. This is 14,000 sine theta, and this is 14,000 cos theta. This is, or there's a constant resistance force of 600 newtons. The power of the car's engine is 22,500 watts. Show that the speed of the car is 11.25. Okay, if the acceleration is 0, that means that the left forces must be equal to the right forces. The left forces are, the right force is the driving force. Let's call that dF. Okay, and the left forces are 614,000 sine alpha. Okay, so I get 600 plus 14,000 into 0.1 dF. I get dF equals to 2000. Okay, then I want to show you the speed. So power is force into velocity, 22,500, 2000 into V. So V comes out to be 11.25, and that is what I had to prove to you. Then it says the car moving with speed 11.25 comes to a section of the hill which is inclined at 2 degrees to the horizontal. Okay, its velocity is 11.25, given that the power and resistance do not change. So power is still 22,500 and the resistance force is 600 newtons. What has changed is the force that the gravity was exerting on the car. So it's 14,000 sine 2. Okay, and there's no other change. Let's call that dF. Okay. Now, since I don't know the acceleration, that's what I'm trying to find, initial acceleration. What I'm going to do is I'm going to use the velocity to find the driving force. Driving force into velocity is 22,500. So dF equals to 22,500 divided by 11.25. That should give me 2000. Okay. So the driving force is now 2000. There's R. Now, if I'm trying to find the acceleration, I'm going to say that F equals to ma, where F is the net force. So I'm going to say that 2000 minus 600 minus 14,000 sine 2 equals to 1400 A. And I'm going to solve this and say that the acceleration should be 0.651 meter per second squared. Okay. Now, this question says that a particle of mass 0.2 kgs is held in equilibrium by two light inextensible strings, PQ and QR. P is a fixed point on a vertical wall and R is a fixed point on a horizontal wall. The angles which strings PQ and PR make QR make are 60 and 30 respectively. Find the tensions in these two strings. So when this particle is being pulled up, can I say that the tensions are moving down? Let's call that TR and let's call that TP. Okay, there's the weight here. That's 2. If I resolve these two tensions, I get TP sine 60, TP cos 60, TR cos 30, and TR sine 30. Since there's equilibrium, I'm going to say that up equals to down and left equals to right. So up I have TP sine 60. Down I have TR sine 30 plus 2. If I do 3 over 2, half TR plus 2. Left is TR cos 30 and right is TP cos 60. So I get half TP root 3 over 2. These are the calculations for the angles. So TP is basically root 3 TR. If I use the substitution here, root 3 TR half TR plus 2. That gives me 3 over 2 TR equals to half TR plus 2. 3 over 2 TR minus half TR equals to 2. So TR is basically equals to 2. And TP should then be root 3 into 2, which is 3.46. This question is kinematics. And says an elevator moves vertically supported by a cable. The diagram shows a velocity diagram from time graph, which models the motion of the elevator. The graph consists of 7 straight line segments. The elevator accelerates upwards from rest to a speed of 2 over a period of this, and then travels at time t before decelerating. The elevator then remains at rest for 6 seconds before the accelerating to a speed of this. Find the acceleration of the elevator during the first 1.5 seconds. Okay. So this is simple. Acceleration is simply the gradient of this line. So I'm going to say y2 minus y1 over x2 minus x1. That's the change in velocity over the change in time. That's 4 over 3 meter per second square. Okay. Then this says, given that the elevator starts and finishes this journey on the ground floor, find V. If it starts and ends its journey, then I can say that this distance should equal this distance. They're both trapeziums. So I'm going to say that area of trapezium 1 should equal area of trapezium 2. Okay. For area of trapezium 1, I have a height of 2. And I have a parallel side is 4.5 and the other one is 7. For this one, I have a height of V and I have parallel sides as 5 and this one should be 8.5. So half height and then sum of parallel sides. And half height is V. The parallel sides are 5 plus 8.5. Okay. Solving for V should give me 11 point. It's 1.7037. Correct to three significant figures, it would be 1.70 meter per second. It's the value of V, so I can ignore the units. It says the combined weight of the elevator and the passenger on its upwards journey is 1,500 kgs. Okay. That there is no resistance to the motion, find the tension in the elevator cable on its upwards journey when the elevator is decelerating. So there's a tension that's pulling it up, there's a weight that's pulling it down, and that's 15,000. What I need to know is that it's still going up, but it's decelerating. So what is its deceleration? Can I quickly find the gradient of this line and tell you that the deceleration should be 2 minus 0 over 6 minus 7, which is minus 2. So I'm going to say that it's accelerating at minus 2. So T minus 15,000 equals to 1,500 A. T minus 15,000 equals to 1,500 into minus 2. So the tension in the cable is 12,000 newton. This is question number 5. And this looks like Newton's laws. It says the block of mass 5 kgs is being pulled on a rough horizontal surface by a force magnitude x at 30 degrees. The block starts from rest and travels 2 meters in the first 5 seconds of its motion. It started from rest. So U is 0, S is 2, T is 5. I'm asking you to find the acceleration. So S equals to ut plus half at squared. S is 2, U is 0, T is 5 plus half a 5 squared. So I get acceleration as 4 over 25, which is 0.16 meter per second square. Okay. Given that the coefficient of friction between the block and the floor is 0.4, find x. So now I know my forces, I know the acceleration. Let's just resolve this. Okay. This is going to be x cos 30, x sine 30, There's a normal component called R. There's a downward component that's 50. There's a friction pulling it back called FF. Okay. So there are two unknowns. I'm going to say that it's in vertically in it's in equilibrium, it's moving horizontally along a rough horizontal course. So I'm going to say that R plus X sine 30 should equal 50. And for the horizontal portion, I'm going to say that F equals to MA. F is X plus 30 minus the frictional force equals to MA. 5 into 0.16. Okay. Frictional force is written as mu into R. 5 into 0.16 is 4 over 5, which is 0.8. Okay. Mu is given as 0.4 R. 0.4 and then I have R. Can I replace R? This is 0.5x, sine 30 is 0.5. Can I replace R with 50 minus 0.5x? 50 minus 0.5x is 2.8. Okay, I have x root 3 over 2. 0.4 into 50 is 20. And 0.4 into 0.5 is 0.2 plus. Okay, 20.8. Okay, I can factor out an x and then say that 20.8 divided by 0.3 over 2 plus 0.2. And I get x as 19.512 to 19.5 newtons. Find x, so 19.5. Okay, then says that this entire question then says that the block is now placed the block is now placed on a part of a floor where the coefficient of friction between the block and the floor has a different value. Okay, so we have the same things. Okay, the block is 5 kgs. It's still being pulled up. This time it's 25. And 25 cos 30, 25 sine 30. I have R. There's mu into R. And that's the mu is what value is what I want to find. And then there's gravity. And this time there's an equilibrium. So I'm going to say that R plus 25 sine 30 should equal 50. Plus this becomes 12.5. So R is 37.5. For the horizontal, I have mu R equals to 25 cos 30. Mu is what is required in the question. So mu comes out to be 0.577. Okay. Then we have kinematics again. A particle moves in a straight line, starts from rest at a fixed point O. Its velocity at time t seconds after leaving O is v, where v equals to t square minus this. Find the displacement of the particle from O when t equals to 1. Okay, so I can basically just simply integrate and find the expression for S. I could also use limits directly and say that when I have this and I just want to find the displacement, I can just integrate with limits 0 to 1. Okay, that would help me get rid of the idea that I need C. T cube over 3 minus 8t power 5 over 2 divided by 5 over 2 plus 10t square divided by 2, and I have to insert the limits 0 to 1. So 1 cube over 3 minus 8 1 power 5 over 2 divided by 5 over 2 plus 5 into 1 square minus all the terms are 0, so all of them become 0. I can ignore that and tell you that uh, the final answer should be 2.133, or you can also tell me that's 32 over 15. Okay, it's the first part. Show that the minimum velocity of the particle is minus 125 meter per second square, meter per second. This is a 7-mark question. Let me just write this down first. What I'm trying to find is the minimum velocity. So what I need to find is the turning points of this curve that I have in front of me. Okay. So I differentiated dv over dt 2t minus 8 into 3 over 2 t power half plus 10. I get 2t minus, can I write this as 4 root t plus 10. I need to equate this to 0 to find the turning points. Okay. So how do I solve this question? We learned about disguised equations in P1. So if I square both sides, what I end up with is a quadratic equation. Okay, I see that everything can be divided by 4. So I have 4t, t squared, 10t, and 25. So I have t squared plus 60 plus 1 equals to 0. Okay, I can use my quadratic formula and tell you that the two answers to this equation are that's a mistake somewhere. I just made a small mistake, and this is 12. 12, so this becomes 12. Okay, then I have 144t, 40 squared, 40t plus 100, 40 squared minus 104t Okay, plus 100. Then I use my quadratic formula. And I can then tell you that um, the two values for t, 1 and 25. One of them will give me the maximum velocity, the other will give me the minimum velocity. What I can simply do is instead of trying to I can also double differentiate it and then determine which one is a maximum and which one is a minimum. So this was dv over dt. So I double differentiate it d square v over dt square, and I get 2 minus 6t power minus half. Okay. I can insert the values and say that 2 minus 6 into 1 gives me minus 4, and 2 minus 6 into 25 power minus half gives me 2 into 2 minus 6, 5. Gives me 0.8. So this one is a minimum and this one is a maximum. I wanted to find out the minimum velocity. So I'm going to use this and say that when I plug this in into velocity, t square minus 8t power 3 over 2 plus 10t. T is 25, 25, 25. Minus, okay, that gives me minus 125. That's what the question was asking you to prove. Okay. Okay. This is possibly the last question, and it's a long one. Okay. Let's see what this says. It says two particles P and Q of mass 0.5 and m kgs respectively are attached to the ends of a light inextensible string. The string passes over a smooth fixed pulley which is attached to the top of two inclined planes. The particles are initially at rest with P on a smooth plane inclined at 30 degrees to the horizontal and Q on a plane inclined at 45 degrees to the horizontal. The string is taut and the particles can move on a line on lines of greatest slope of the two planes. A force of magnitude 0.8 newtons is applied to P acting down the plane, causing P to move down the plane. Okay, it is given that m equals to 0.3 and that the plane on which Q rests is smooth. Okay, can I draw the tension here and the tension here? Find the tension in the string. That's what I'm trying to find. Okay. Let's draw five sine 30, 5 cos 30. M in this case is 0.3. So 3 sine 45, 3 cos 45. So this is all friction involved. I can just say that this is going to be a system in action and P is moving. I'm going to say that point 0.8 at P, what's happening is 0.8 plus 5 sine 30 minus T equals to 0.58. At Q, it's T minus 3 sine 45 equals to 0.38. This is a basic simultaneous equation that I can quickly solve. And I can say that 0.8 plus 5 sine 30 minus 3 sine 45 equals to 0.88. So acceleration comes out to be 1.4733. So if I'm trying to find the tension, then I can say that it's 2.56. Okay. Then says it is given that the plane on which Q rests is rough, and then after each particle has moved a distance of 1, their speed is 0.6. The work done against friction in this part of the motion is 0.5 J. Use an energy method to find the value of M. Now, when it says you need to find using the energy method, you have to make sure that you use the work energy principle to solve this question. Okay. Um, let's try solving it with the work energy principle. Okay. And we see what happens. Okay. I can apply the idea to the entire system together, and I can get my answers using that. Okay. So what will happen is first I will write down my work done by driving force equals to change in K plus change in P plus work done by resistance. That's clear. That has to be 0.5. Okay. The driving force in this case is 0.8. Let me first do the calculations then. Okay, the driving force is 0.8. Let's travel the distance of 1. Change in K. Okay, so half for there are two Ks then. One is for P plus 4q, 4p plus 4q plus 0.5. Now, for p, it's half, m is 0.5. They start from rest, and the speed is 0.6 square minus 0 square. For q, it's half, 0.3. Sorry, this time it's m, right? M 0.6 square minus 0 square. Okay. Now, p is going down, so it's losing ke. How much is it going down? This is a 1 meter slope, 30 degrees. So the height has to be 1 sine 30. Okay. So it's losing its potential energy. So I'm going to say minus 0.5 gravity, and sine 30 gives me half. So half. For q, I have m, it's gaining some ground. And since the slope is at 45, 1 sine 45. Okay, 1 sine 45 gives me root 2 over 2 mgh plus 0.5. So yeah, and this is 0.8. So quickly computing all of this gives me what? Let's just multiply the numbers together. It's a complicated calculation. It gives me 9 over 100. So it's 0.009. 0.6 squared divided by 2. That gives me 0.18 m. That gives me, and this gives me 5 root 2 m plus 0.5. 0.8 minus 0.09, sorry, 09 plus 2.5 minus 0.5. It's 2.18 plus 5 root m, 5 root 2 m. Let's see if we have the correct answer then. Some calculation mistake online. Yeah, that's the correct answer. 3737.374. Okay, that's the end of the exam. This last part was tough, but manageable.